Work has been going on for several years to develop technologies for space observation. And today, amazing machines such as the James Webb Telescope have been built. This telescope has left the whole world in awe with its new images of deep space and its amazing discoveries. The telescope uses very powerful space lenses that make it possible to see the first galaxies and stars that formed billions of years ago. After a long period of design and construction, and after several setbacks, the James Webb Telescope is finally producing its first results, representing the impressive outcome of an investment of about $1 billion. We invite you to join us to explore how this telescope has achieved a clear image of Proxima B. And if you're interested in keeping up to date with news about the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell. Thanks to the James Webb Telescope, NASA and its international partners have been able to prove that many of the theories they were exploring are true. The telescope will make it possible to observe phenomena and stars that, until now, were totally unknown to space science. The largest telescope ever built was launched into space on December 25, 2021. It is currently located at the L2 Lagrange point, 1 million kilometers away, in a Sun-Earth halo orbit. Thanks to a 6.5-meter-wide primary mirror and ultra-sensitive infrared instruments, the telescope has been able to detect the distorted shapes of red arcs from galaxies that existed 600 million years after the Big Bang. The universe is approximately 13 billion years old. And what scientists can interpret from the quality of information being produced by James Webb is that the telescope is receiving data about the universe far beyond what had been expected so far. This may be the deepest visual range of the universe we have ever obtained. The James Webb Telescope has achieved a feat never before seen in human history by capturing images of the cosmos that surpass any previous expectations. The first images released by NASA present a completely new vision of the universe, which surprised even the experts. The goal of this mission is to solve the mysteries of the solar system, discover new worlds, and explore the origins and structure of the universe. NASA has worked in collaboration with the European Space Agency, the Canadian Space Agency, and other international organizations to make this project possible. The telescope has captured a hidden history of the universe through every stage of its evolution, allowing scientists to better understand our place in the cosmos. In the images captured by James Webb, exoplanets and distant galaxies can be seen in the deep universe, making it the clearest and most detailed infrared image of the distant universe to date. The first color photograph taken by the telescope was released on July 12, 2022, and did not disappoint. The image, unveiled by President Joe Biden, shows the telescope's ability to fulfill one of its goals: to observe distant galaxies. The image shows a cluster of galaxies in the Volund constellation, known as MAX 0723, which lies at a distance of more than 4.5 billion light-years. The light reaching us from this galaxy was generated when the solar system was forming, and it has traveled across the universe until it reached our eyes today. What is an exoplanet? Well, an exoplanet is a planet that orbits a star other than the Sun and therefore does not belong to the solar system. Of all the exoplanets known so far, none arouses as much interest as Proxima B. As mentioned before, the star orbiting the exoplanet is Proxima Centauri, a very cold red dwarf with a surface temperature of 2,872 degrees Celsius, 8 times less massive than the Sun and 500 times less bright. About 7 million kilometers from its star is Proxima B, which has characteristics very similar to those of Earth, with continents, oceans, and possibly life. Huge auroras give the planet a greenish color in both hemispheres, as a result of the intense flares expelled by its star, forcing the magnetic field to generate these massive auroras. What you see on the screen is the most detailed image that the James Webb Telescope has ever taken of Proxima B. This planet is tidally locked. That is, the same face of the planet always points to its star. This means that the best area for life is a twilight zone. The surface temperature could be between -90 degrees Celsius and 30 degrees Celsius, and it takes about 11 Earth days to complete a full orbit of its star. It has a gravity of about 1.23 times that of Earth. Scientists are not yet certain whether Proxima B has an atmosphere. But if it does, the ingredients such as carbon dioxide, rocks, and water, necessary for the formation of the biochemical cycles we call life, would likely be present on its surface. The Webb telescope has succeeded in finding signs of water on an exoplanet called WASP-96b. The spectrum of the exoplanet's atmosphere has been analyzed in detail by the telescope, revealing the presence of water, haze, and clouds that had not been detected before. Although WASP 96b orbits too close to a star to support life, scientists hope that Webb will be able to study planets with Earth-like atmospheres in the future, looking for signs of life. NASA experts are very confident that Webb will meet its goal. The first list of images released by the telescope is spectacular and has been captured in infrared, including photos of the Southern Ring Planetary Nebula and a star covered in dust and light. The scientist in charge of the project, Dr. Amberstrand, is excited about what they will be able to do with these images in the future. The James Webb Telescope gives us a stunning view of Stephan's Quintet, a group of galaxies in the constellation of Pegasus, with clouds of dust surrounding its center. Stephan's Quintet is composed of 5 main galaxies: NGC 7317, NGC 7318A, NGC 7318B, NGC 7319, NGC 7320. These galaxies are gravitationally interacting with each other, which has resulted in interesting and peculiar features in their structure. NGC 7317 is an elliptical galaxy that appears to be relatively isolated from the rest of the group. NGC 7318A and NGC 7318B are 2 merging galaxies that have generated intense star formation activity. NGC 7319 is a barred spiral galaxy with a deformed spiral arm due to interactions with the other galaxies in the group. Finally, NGC 7320 is a smaller spiral galaxy that appears to be farther away from the group and not interacting as directly with the others. Stephan's Quintet is an intriguing object of study for astronomers, as it offers an opportunity to better understand how gravitational interactions can influence the evolution of galaxies. These interactions can trigger star formation, transform galactic structures, and eventually lead to mergers between galaxies. The study of compact groups of galaxies, such as Stephan's Quintet, helps advance our knowledge of galaxy formation and evolution in the universe. In addition, through its view of the Carina Nebula, Webb gives us a rare look at stars in the early stages of formation, studying the gas and dust that created them. Webb's ability to detect essential molecules will be vital in searching for organic traces on exoplanets. The telescope will continue to orbit and provide images and data of the universe. It is hoped that in the future, it will be able to study a planet with an Earth-like atmosphere in search of life. Although we cannot predict exactly what Webb will show us in the near term, it is fulfilling its noble task of helping us learn more about our vast universe. We cannot say for sure whether the James Webb Space Observatory will provide us with information about the existence of extraterrestrial life beyond our solar system. However, the telescope will continue to provide new data and discoveries about the universe, and it's exciting to think of the possibilities this may present. If you like this video, we appreciate your support by liking, sharing, subscribing, and turning on the notification bell to stay updated with our new content. See you soon. As the James Webb Space Telescope continues to send back unprecedented data, the scientific community is only beginning to grasp the full extent of what this revolutionary observatory can achieve. Beyond capturing beautiful cosmic images, Webb is transforming our understanding of how galaxies, stars, and planetary systems evolve over time. Each new image, each dataset, is not just a glimpse into the distant past. It's a piece of the puzzle that helps decode the origins of the universe itself. One of the most groundbreaking aspects of Webb's mission is its ability to peer into the atmospheres of exoplanets, planets that orbit stars outside our solar system. Using a technique called spectroscopy, scientists can analyze the light filtered through these atmospheres during a planet's transit across its star. This allows them to detect the presence of gases such as water vapor, carbon dioxide, methane, and even ozone, potential indicators of life or habitability. Perhaps even more exciting is Webb's capacity to observe so-called habitable zone planets, those that orbit at just the right distance from their stars to support liquid water. While Proxima B is one of the most famous candidates, there are dozens of similar planets waiting to be studied. With time, Webb could be the first telescope to provide strong evidence of a truly Earth-like planet orbiting a distant star. Webb is also shedding new light on cosmic events that are both ancient and powerful. By observing supernovae, black holes, neutron star collisions, and the energetic processes within quasars, it is helping to map the violent and dynamic side of the universe. These observations are critical to understanding how elements necessary for life, such as carbon, nitrogen, and oxygen, are formed and distributed across galaxies. The telescope's sensitivity in the infrared spectrum allows it to see through cosmic dust clouds that block visible light. This is especially important when studying star-forming regions like the Carina Nebula or the Pillars of Creation in the Eagle Nebula. These are the cosmic nurseries where new stars and planets are born, and Webb is giving us the clearest view yet of these processes. In addition to its scientific goals, the James Webb Telescope is also serving as a symbol of international cooperation and human curiosity. It represents the combined efforts of thousands of scientists, engineers, and technicians from around the world, all working together toward a shared vision to explore the unknown and push the boundaries of what's possible. As Webb continues its journey, orbiting silently at the second Lagrange point, it reminds us of how far we've come in our quest to understand the cosmos, and how much further we still have to go. With each image it sends back, we are not only learning about distant galaxies or alien worlds, but also deepening our understanding of our own place in the vastness of space. The future of space exploration is brighter than ever. New missions are already being planned to build on what Webb discovers. Telescopes even more powerful are in the works. Space observatories focused solely on exoplanets are being conceptualized, and private space exploration initiatives are expanding access to the stars. In the coming years, the James Webb Space Telescope is expected to play a crucial role in identifying potential biosignatures, the subtle signs of life on distant planets. If such a discovery is made, it would not only be a scientific milestone but a profound moment for all of humanity. It would change our understanding of life itself and our uniqueness in the cosmos. We are witnessing a new golden age of astronomy. And thanks to James Webb, the next great discovery could be just one orbit away.